Hello everyone, welcome to Narayana Educational Society, and here I am Shivanand Upadhyay for JEE 2026 paper discussion. And this time we feel that the paper quality is very good. I think IIT people are using AI to improve the question paper. So let us start the discussion. The first question is, an ideal gas initially at 2 bar pressure is compressed at a constant temperature of 600 Kelvin in 2 steps. First, against a constant external pressure of P bar, where the P value can lies between 2 to 8 bar, and then against a constant external pressure of 8 bar. At each step, the compression is stopped only when the pressure of the gas becomes equals to external pressure. The total work done on the gas in these steps is W. Considering all possible values of P and taking the gas constant as R, the minimum value of magnitude of work done in Joule is. So this type of question we are doing, but there is a twist in the question. They are asking for the minimum value. So it is a two-step process. If I try to draw the pressure versus volume graph for this, so pressure versus volume graph, the gas is subjected to compression. We are at initial state A, and then we are moving from state A to state B, and then from state B we are moving to state C. So if we look into the graph, we can see here that we are moving from A to B point and the external pressure is constant, right? So if we try to write that what is the work done, if I show it with the help of a graph, then if I draw pressure versus volume graph, initially we are at some position and then we are moving to another position here, where the pressure will be equal to, initially the pressure was 2 bar, but the gas pressure is less, and then we compress when the pressure of the gas is equal to 2 bar, this process will stop. So work done under this condition will be this area under the curve, where the pressure here is equal to, initially we are at a pressure of 2 bar and now the pressure is equal to P bar, right? When the pressure of the gas is equal to P bar, then this step is going to be complete, right? So this is the work done here. We can say that this is the initial volume V1 and now the volume is at V2. Then at the second step, we are keeping the external pressure is 8 atm, right? And if we try to show on the pressure versus volume graph, this should be the graph for this step. So there is a problem while making the graph, so that's why I'm not able to explain all those things, right? So here in short I can say that we are moving in two steps. While moving in step 1, the work done is equal to minus times of P external. Since it is compression, if I write final work done should be positive. So we are starting against a constant pressure of P bar, and I am writing the magnitude of work done. Since it is compression, the magnitude of work done or work done will be same. So pressure into volume change, so V1 minus V2, because I have to make it positive, so V1 minus V2. So this is the work done in the first step, and then we can write that the work done in the second step is equal to, now the external pressure is 8 atm and the volume change here will be V2 minus V3. I have to write the positive value only, so V2 minus V3. And if we write what is the total work done in this process, so total work done is equal to work done in step 1 plus work done in step 2. So pressure V1 minus V2 plus 8 times of V2 minus V3. Initially they have given that half moles of gas is there and the gas pressure is 2 bar. So if I calculate that what is the value of V1, I can write number of moles of the gas R into T divided by final initial pressure was 2 bar, so I can put here 2. So this is the initial volume. I am not putting the value of number of moles, and temperature we can put it finally because it is an isothermal process, so number of moles and temperature being constant. Similarly, I can calculate what is the volume V2. So V2 we can write that is equal to nRT. Final pressure at V2 will be P, and then final volume V3, that is equal to nRT divided by final pressure is equal to 8 bar. So if we put this value, I can write that the total work done is equal to pressure we have to take that P only, and then V1 I have to put the value. So nRT divided by 2 minus V2 is equal to nRT divided by P, then 8 times of V2 we are writing nRT divided by P, and V3 is equal to nRT divided by 8. So if I simplify this, I can write that the work total is equal to P and nRT we can take outside. So nRT, and I'm taking nRT common and I'm entering this P inside, so that is P divided by 2 minus 1. Again here nRT I can take common, so I can write 8 by P, and this will be minus 1. So if we want to calculate what is the minimum or maximum value of work done, for that we have to differentiate work done with respect to pressure. So on differentiating this with respect to pressure, nRT is constant, and differentiation of this is 1 by 2, and if I differentiate this, I can write this is minus 8 upon P square. This should be equal to 0. From there we can calculate what is the value of pressure. So the pressure coming is equal to 4. And if we have to find out, because they are saying minimum value, if you want to check, you can double differentiate it. So d square W upon dP square, you can write this nRT will be constant, differentiation of half will be 0, and this will be minus 8 minus 2 P to the power 3. So if you simplify, this value is coming positive. So from here we have decided that it will be minima. And now if we put to get the minimum value of work done in this equation, I can write that nRT in place of P I can put 4. So 4 divided by 2, and this minus 1 and minus 1 will be minus 2. 8 divided by 4. So if we simplify this, we are getting this value is equal to nRT. This will be 2 and 2 will cancel out. Finally we are getting 2. If we put now the number of moles is equal to half, we have to write in terms of R, and temperature throughout the process is 600 Kelvin. From this we are getting that this value is equal to 600 into R. So answer for this will be B. Moving to the next problem. An ideal, okay, next problem. For a reversible reaction, R will form product at a constant temperature. Both the forward and backward reactions are first order elementary reactions with rate constant K forward, K backward respectively at time t is equal to 0. The concentration of R is R0 and the concentration of P is 0. At any time t, R and P are the concentration of R and P respectively, and Kb is equal to 4 times of Kf. The correct graphical representation of this reaction is, so from many years, I think in coaching industry 10-15 years, more than that, we are teaching this reversible reaction opposed by a first order reaction opposed by a first order reaction, and now in 2026 they have asked this question. So very routine question. So let us try to solve this. R will form P, and initially at time t is equal to 0, there is only R, and its initial concentration, they are saying that initial concentration is R0. As the reaction proceed at any time t, if we try to write what is the concentration, we can write that R0 minus X, and we are interested in equilibrium, so we can write that R0 minus X equilibrium, and this will be X equilibrium. So according to the given equation, if I try to write that what is the condition for equilibrium, I can write that the rate of forward reaction is equal to rate of backward reaction, and Rate of forward reaction is equal to rate constant of forward reaction. Concentration of reactant at equilibrium is equal to R naught minus X equilibrium. Rate of backward reaction is rate constant of backward reaction into concentration of product at equilibrium is X equilibrium. According to the given condition, they have given that the value of K backward is 4 times K forward. So if I put here 4 times of K forward into X equilibrium is equal to K forward R naught minus X equilibrium, and if we try to simplify, K forward will cancel out, and we can write that R naught is equal to 5 times of X equilibrium, or X equilibrium is equal to R naught divided by 5. So this value will be 0.2 times of R naught. So we got that when 20% of reactant is converted into product, there is an equilibrium state. So if we try to draw the diagram of the reactant, how it is going to change with time, initially suppose if on y-axis they have represented R upon R naught. So we have to write that the initially at time t is equal to 0, this ratio is equal to 1. And as the reaction is proceeding, the concentration of reactant is decreasing with time. So this is there, and at the equilibrium state, when only 20% of the reactant is consumed, here we can see that this ratio becomes 0.8 times. So this is the variation of concentration of reactant for product. Initially at time t is equal to 0, there is no product at all, and as we are moving, after some time when equilibrium is established, the amount of product formed is equal to that 0.2, right? So from here this ratio is equal to 0.2. So from here we can decide that C graph is the correct one. So answer for this question will be C. So very straightforward question it is. If someone has done first order opposed by first order, I will say that this will be an easy question. So let us move to third problem. The third problem is from chemical bonding, and it's very simple problem. They are asking about dipole moment. So the chemical species are BF3, NH4 plus, NF3 and NH3. For BF3, if we discuss about the central atom, the hybridization of central atom is sp3. So the fluorine atoms will be attached to this boron atom at an angle of 120 degree. There is no lone pair over here. So if we try to place the dipole moment vector, it is from less electronegative atom to more electronegative atom, and because of symmetry at the central atom, we can say that all surrounding atoms are same. And there is no lone pair. So because of symmetry, we can say that the dipole moment is equal to 0. The same concept I can apply for the second option, because this positive charge is there on nitrogen atom and there are 4 hydrogen atoms attached to this nitrogen atom. So again, if we see that all the surrounding atoms are same, this condition is satisfied. There is no lone pair on the central atom, right? So because of symmetry, we can say that these all dipole moments will cancel out each other. So the dipole moment of NH4 plus is equal to the dipole moment of BF3, and that is equal to 0. So this is there in one option only. From here only we got the answer, because there is no other condition where BF3 dipole moment is equal to NH4 plus. But again, if we try to solve those two options, in case of NF3, it has a lone pair on nitrogen atom and 3 fluorine surrounding atoms are there. So if we try to show the dipole moment here is moving from nitrogen to more electronegative atom, that is fluorine atom. So these 3 dipoles are in this direction, but because of lone pair, the dipole moment is in upward direction. So these 3 vectors and these vectors are not in same direction. If we discuss about NH3, in case of NH3, the same type of structure is there. there is one lone pair on nitrogen atom and 3 hydrogen atoms are attached to it, but nitrogen is more electronegative, so the direction of dipole moments, all the dipole vectors are towards the same direction and they are additive in nature. So if we see the experimental data also, the dipole moment of this is 1.47 dBi, while the dipole moment of this is 0.24 dBi. So obviously by solving the first two option only we got A as correct answer. So the fourth question is discussed by my colleague Neha ma'am.
So, hello, now let's start the organic portion of 2026 JEE Advanced Paper 1. As you all know, organic this time was relatively little more than other contents of organic chemistry and is also little tricky. So, let's have a detailed discussion of all the possible questions. So, first question, paper 1 of organic is question number 4. What does it say? Considering LiBH4 reduces an ester group. So the information is already given in the question that it reduces an ester functional group, right? If this information is already mentioned, it eases out our attempt to the corresponding alcohol that also is given and does not reduce carboxylic acid group. A very important piece of information is already given in the question, but still there will be problems. The correct statement about the major product P, Q, R and S, 4 products you have to analyze. So let's start each and every possible product. So the first portion, let us make the solution. What does it say? Is that first we have CH3, then there is wedge dash COOET, and here we have COH. Now this molecule is treated with LiBH4 first. Okay, LiBH4, as the question has already mentioned, that it will reduce ester to alcohol. Fine, but followed by H plus. And when it says followed by H plus, if you have read the NCERT carefully, it has clearly mentioned that acid and alcohol, if placed in acidic medium in presence of HCl or H2SO4, esters are formed. So let us draw the possible product, CH3, right? So wedge, here wedge. Now this thing will become CH2OH. So this is O. Why I am writing only O? Because that O will react with this COH and ester is formed. This particular is P. Along with this, definitely ethanol is also obtained because this portion will go for ethanol. The other set of reaction is BH3 as a reducing agent and then again H plus. Again, go back to NCERT reading. NCERT says BH3 is like one of the best possible reducing reagent for carboxylic acid. It will not reduce ester or nitro or other functional groups with ease, or for practical purposes not reduce at all. So by that logic, this time what is happening here, it remains COET, okay, and here this is become CH2OH. Now when I say O, there is ester formation again, where this side alcohol will react with this side ester, and you must have been seen or studied a reaction named transesterification, when one ester is converted to another ester in presence of alcohol. So that reaction is observed here, and the product this time formed is mentioned as Q. Okay, this is dash. Now, if you observe P and Q carefully, yes, you will find them to be optical distereomers. First thing, observe stereomers. Okay, but other method, you could have also approached it by RS configuration. If this is on wedge, then hydrogens must be on dash. Considering CIP priority, let's change the color. For this carbon, if I want to do CIP priority, the most preferred is this lower arm, right? Second preference will be this upper arm. Third is this methyl group. And already the lowest priority is on dash. So I can see this is a R configuration chiral center. That center in fact is chiral and is R chiral center. So this is R. Going to this one because this is also chiral. Let us draw for this. For this, the maximum priority will be for the dash. Then it will be C. This is also C. This is also C. But this is further attached to C. This ultimately will go to oxygen. So second, and this one is third priority. But as you can see, the thing is on dash, right? So if it is on dash, then whatever I will obtain will be opposite of the actual answer. Is that clear? Whatever I will obtain will be opposite of my actual answer. So better I first make exchanges. This fourth is kept here on dash. First, second, third, anti-clockwise. So I'll report this answer also as R because after the exchange, I got anti-clockwise. Before exchange, it must have been clockwise. Considering to same CIP priority here, this is R. And this, as you can see, is on wedge. Okay. And this one is on dash. See, there is interchange of groups. So this configuration this time will come S. You can also attempt and get the answer by yourself. So 2 chiral center are R, 2 chiral center are S. And what is the relationship? They are optical isomers of each other. So we are calling it optical diastereomers. Coming to options, P and Q are identical. This can't be answer because we just proved these P and Q are diastereomers. So no, P and Q are diastereomers. Yes, still in the race. D option also to be eliminated because it says P and Q are identical. Right? Now let us see amongst B and C what to select. RS are identical or are diastereomeric. There is a slight relocating CH3 positioning. So let us now go for the second reaction. What does the second reaction says? It has the methyl on the wedge but is positioned here, right? Rest is same, that wedge, then C, O, OET, dash, right? Dash and COOH. Same story repeats. LiBH4, reduce it to alcohol, and then H plus is given, so ester will be formed. Once I'll form an ester, the structure is CH3O double bond. Whereas with BH3, reaction is same, just the positions are changed, so the reaction discussion is identical, right? Again, the same change, that ester remain unchanged, so you will have oxygen here and acid part is reduced, so you'll have alcohol backside, right? But these are not chiral. See, this is having a plane of symmetry. These both centers are chiral, but still there is geometrical diastereomerism. See, this CH3 on wedge, then the arm with CH2 is on wedge. Whereas the second case, CH3 and CH2 carbonyl arm is on wedge. So there is this wedge dash type of difference, but it is not the difference of optical isomerism. So this time These two, which are these two? R and S. These were the names. These two are geometrical diastereomers. Geometrical diastereomers. I hope you already know what is the definition of diastereomers. Diastereomers are such stereoisomers, whether they are optical or geometrical, which are not mirror images of each other. So, any two stereoisomers which are not mirror images of each other are called diastereomers, be it optical, be it geometrical. Coming back to options, so we decided PQ are diastereomers and RS are also diastereomers. So let us select the correct choice. Answer is C. Right? I think this question should be from moderate to tough zone. It is not that easy to identify the exact diastereomeric relationships between all these PQRS. It is a time taking process, and that H plus will result in ester is also to be spontaneously taken care of. Okay, so now let's move to next question. Question number 5. Shivanand sir will continue with question number 5.
So, question number 5 is a question which is given in NCERT also, and it is a question of atomic structure. So, the question is the 2s and 2p orbital energies of hydrogen atoms are E2SH and E2PH respectively, and the 2s and 2p orbital energy of lithium atom are E2S lithium and E2P lithium respectively. The correct options about the orbital energies is R. So we know that for single electron system, the energy only depends on principal quantum number. Single electron system, energy only depends on principal quantum number. But for multi-electron system, energy depends on principal quantum number as well as azimuthal quantum number, n plus L rule, right? So here when we are discussing about hydrogen atom, for hydrogen atom if I am talking about 2s and 2p, the value of n is 2. So for hydrogen atom, if the value of principal quantum number is same, the energy will be same, right? So from here we can say that the energy of 2s for hydrogen is equal to the energy of 2p for hydrogen atom, right? So if we look to the B option seems to be correct. Now in case of multi-electron system, the energy depends on principal quantum number as well as azimuthal quantum number. So if we find out that what is n plus L value for 2s suborbit or atomic orbital, that value is equal to 2 plus 0, which is equal to 2, and for 2p if we calculate n plus L value, that is equal to 2 plus 1, which is equal to 3. So obviously the energy of 2p orbital is greater than the energy of 2s orbital in case of multi-electron system like lithium. So from here we can say that the energy of 2p in case of lithium is greater than the energy of 2s, right? So if we look at the options here, A option, energy of 2s for lithium is less than energy of 2p for lithium. A option will be correct. Moving to the C and D option, again if we check here, if we compare hydrogen atom and lithium atom, we know that as the value of atomic number is going to increase, as Z increases, the value of Z effective is going to increase. So if we take the same orbital, that is 2s, and the energy of 2s orbital in case of hydrogen atom where the value of Z is equal to 1, while the energy of 2s in case of lithium atom where the value of Z is equal to 3. So if higher the value of Z, more will be the Z effective. It means more force of attraction, means less energy, right? So if we talk in terms of energy, the energy of electron in 2s of hydrogen atom should be greater than the energy of electron in 2s of lithium atom. So if we go through this, this is a smaller value but the sign is negative, and this is a bigger value but the sign is negative, and you know that with energy we always see the sign. So by taking that in care, we can say that D option is correct. So answer for this question is A, B and D. So very nice question taken directly from NCERT. So most of the students know about it. So now let us move to the next problem. The next problem is of inorganic chemistry, and Neha madam will discuss this question.
So coming to this question of inorganic, which is again directly taken from NCERT. The entire inorganic this time, if you see, is directly picked from NCERT. As I can see, there is slight typing error like MnCl2 plus X, greenish yellow gas was written here, and plus H2O was also produced in the reaction. Now this X, which was produced by reaction of HNO2 plus concentrated HCl, this is the reaction that we used as a test even in salt analysis. Given in NCERT, I'll show you, right? Or you can check in the D block, it is directly mentioned MnO2 plus concentrated HCl will liberate chlorine gas. Greenish yellow gas is again a hint. So by that we identify, okay, X is chlorine gas. Now ammonia plus X. So what is this X? So this X, as we identified, is chlorine gas. Coming to NCERT extract, it says ammonia plus 3Cl2. When chlorine is taken in excess, then NCl3 plus HCl is formed. Okay, let me take you to the exact cutting of NCERT. What is mentioned there? Let me tell you. With excess ammonia, chlorine gives nitrogen and ammonium chloride, whereas with excess chlorine, nitrogen trichloride, which is an explosive, is formed. So this reaction is used by JEE for this question. Ammonia plus excess of chlorine forming NCl3. Right? So coming back to our question, it was ammonia plus excess of chlorine, NCl3. So why is NCl3? Now this X, what was X? Going back to here, X, chlorine. So now again from NCERT interhalogen subtopic, you will find chlorine plus fluorine if taken in excess, 3F2, where considering excess as mentioned in the question. Temperatures are also important, 573 Kelvin. Then the product formed is ClF3. Okay, these are the informations mentioned in the NCERT directly in P block halogen chapter or halogen group. There these two reactions are given. Now let us start. What are the options? Let us start the options. A is used for sterilizing drinking water. X is used. So what was X? Chlorine. Yes, we use chlorine as a bleaching agent, as a sterilizing agent for drinking water. It is sold under several commercial names. Some of them are like ChloriClean, ChloriWatt. These are the some commonly commercial names used for chlorine to be used or added to the drinking water. Okay, so this statement is true. Moving to next, Y has planar structure. Now if I see NCl3, it is pretty much like NF3 as sir has discussed, or NH3. Now it cannot be a planar structure. It is not a planar structure. It is going to be a pyramidal structure. Correct? It is a pyramidal structure where N lone pair, and instead of 3H, there will be 3 chlorines. So this statement is untrue, it cannot be used. Coming to C, Z is used in the enrichment of U-235, uranium-235. Now, how do we know this? What was Z? Z was ClF3. Again, go back to NCERT halogen chapter. You will find in the uses of halogen. Okay, so what is there? Uses of halogen. These compounds can be used as non-aqueous solvents. Interhalogen compounds are very useful fluorinating agents. Okay, ClF3 and BrF3 are used for the production of UF6 in the enrichment of U-235. Okay, so it is directly given in the NCERT that it is used for enrichment of U-235 for the production of UF6, reaction also given, and that ClF3 itself is becoming ClF in the process. Absolutely okay. So looking at this information, Z is used for enrichment, correct. So we'll go for C. Last option, Y is a stronger Lewis acid than ammonia. Going back to Y, this was Y, NCl3. Now it has electron withdrawing groups. If NCl3 accepts H+, how could it be more stable than NH4+? If it was ammonia and H+, the conjugate acid formed would have been NH4+. So I think you would definitely conclude directly that this is an untrue statement. NCl3 is not a stronger Lewis base than ammonia, and therefore the answer for this question is A and C. Is that absolutely okay? Answer is A and C.
So question number 7, this question contains two topics. One is coordination compound and the other is chemical bonding. Reaction of PTF6 with oxygen O2 gas results in the formation of an ionic compound X plus Y minus. Correct statement is R. The bond order of X plus is 1.5. Valence d orbitals of the metal in X plus and Y minus has 5 electrons. PTF6 act as an oxidant in this reaction. PTF6 acts as a fluorinating agent in this reaction. So this question statement is taken from P block, where we are studying reaction of inert gases. So the formation of first compound was motivated by a red color compound formed by the reaction of PTF6 with oxygen, and the ionization energy of O2 and the ionization energy of xenon is almost equal. Since this compound is red in color, there is formation of O2 plus PTF6 minus, right? So this red color compound is O2 plus PTF6 minus. So here we can say that this is X plus and this will be Y minus. So the bond order of X plus, we are writing about O2 plus. By using molecular orbital theory, I can write the electronic configuration sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. If the number of electrons is greater than 14, then sigma 2pz will come first, then pi 2px, pi 2py, pi star 2px, pi star 2py, and finally we will write pi star 2pz. Okay, so this is pi star 2py, and if we try to fill the electrons, 2 electrons here in each, then sigma 2pz, it has 2 electrons, pi 2px has 2 electrons, pi 2py has 2 electrons, pi star 2px and pi star 2py has 1 unpaired electrons, right? And from this we are saying that oxygen is paramagnetic in nature. Now if we remove 1 electron from this, the last one, there is 1 unpaired electrons, right? We are removing anti-bonding electrons, so bond order should increase. So the first option is wrong, because here if we try to find out the bond order will be 2.5. The valence d orbitals of the metal ion in X plus and Y minus has 5 electrons. So the anion in this is Y minus, and Y minus is equal to PtF6 minus. From here, if I calculate what is the oxidation state of platinum, so minus 6 is equal to minus 1. From there, we are getting that platinum is present in plus 5 oxidation state. Again, for D block elements, nickel, palladium and platinum, both palladium and platinum has exception in electronic configuration, because if I write electronic configuration of nickel, that is 3d84s2, while in case of palladium it is expected that 4d8 and 5s2, but these two electrons move from 5s to 4d, so it is 4d and 5s0, and in case of platinum it will be 5d9 6s1. This is the electronic configuration, so this is also very important here. So now platinum is present in plus 5 oxidation state. So platinum plus 5 oxidation state, if I try to write what is the electronic configuration of this, so I have to remove 1 electron from here and 4 electrons from here. So I will get 5d5 6s0. Right, we have removed 5 electrons from these 10 electrons. So they are asking that the valence d orbitals of the metal in X plus Y minus has 5 electrons. This B statement seems to be correct. PtF6 act as an oxidizing agent because oxygen is losing 1 electron to form O2 plus, while PtF6 is gaining 1 electron to form PtF6 minus. So obviously PtF6 is acting like an oxidizing agent. C option is correct. Here PtF6 is not donating its fluorine to oxygen, right? So it is not acting like a fluorinating agent. So D option is wrong. So answer for this will be B and C.
So here is the next question of organic, and let us see what all reactions are involved. The first reaction in the following sequence, we have to identify QRST as major product, and based on those QRST, we have to select the correct statements. Okay, so what are the reactions involved? Let's go step by step. Now, first, they have given CH3 COONA and reaction name directly given, that do coal-based electrolysis. Okay, coal-based electrolysis will form alkanes and along with coupling. So this alkyl part will be coupled. What will I get? I will get N-hexane 1, 2, 3, 4, 5, 6. So product here is N-hexane. Step 2 is V2O5 at 500 degrees centigrade and 10 to 20 atmospheric pressure. Now this pressure is sufficient to cause aromatization. This is aromatization of alkanes and the product is benzene. So Q formed. We have got the Q. Now this Q is taken forward for the next reaction. Seeing what is the reaction, phthalic anhydride is used. Now phthalic anhydride along with AlCl3 is a famous reaction, Friedel-Crafts acylation. What they are doing is a Friedel-Crafts acylation. So what will actually happen? This attacked by AlCl3, right? Here there is resonance and this moves away. So I'll get a acylium ion which is attacked by benzene. Let us see what product we will get. C double bond O, right? And when I'll remove this AlCl3, the H which is coming from here will make this center COH. Okay, so this is my structure for R. Now for R, they are again giving us that treat it with PCl5. Okay, I treat it with PCl5. It's a wonderful question, maintaining the limits of NCERT and still using all possible good reactions as well as some of the very famous name reactions. So acid chloride will be formed, PCl5 and carboxylic acid chloride is formed. No PQRS name is assigned to this. Moving forward, it says take palladium poisoned by barium sulfate and hydrogen. So it is a hydrogenation reaction, reduction reaction. And I hope all of you must be identifying this reaction as it is famous Rosenmund's reduction. Right? It is Rosenmund reduction reaction. So Rosenmund reduction reduces acid chloride only, not ketones. Okay, ketones remain as such and acid chloride is converted to aldehyde. This is our structure of S. Now they say S is, let me repeat right, S first. S is treated with hydrazine, CH double bond O. It is treated with hydrazine. Okay, and heat, remember it is not Wolff-Kishner reduction. There is no QH given. Several students might have done an error at this point, that is it Wolff-Kishner reduction, because you are very familiar to hydrazine plus concentrated KOH forms alkanes. No base is given, so it is not Wolff-Kishner. Then what it is? It is ammonia and derivative addition reactions, right? So 1, 2, 3, 4. 4 carbons, 5, 6. 2, 1 will add here, other will add here like this. Okay, so what will I get? Let me check. So as we said, carbon, this will combine with this nitrogen, CH will combine with this nitrogen. Okay, and this carbon will continue to have this pH. So we will have this pH here. And is any name assigned to this structure? Yes, T is assigned to this structure. Let us move backward. What are my options? S, on warming with ammoniacal AgNO3 results in the formation of silver mirror. So let us check what was S. What was S? Yes, it has aldehydic group. It will give tolerance reagent test. So warming with ammoniacal AgNO3 will result in the formation of silver mirror. Correct option A will be part of our answer. Okay, moving to B. Q, on treatment with chlorine excess in presence of ultraviolet light gives gemexine. Let us check what was Q. Q is benzene, and true, very true. Benzene, on treating with excess of chlorine and HNO, forms C6H6Cl6, which has 9 different isomers. And some of its isomers are very well known, pesticides and insecticides. One of them is gemexine, insecticide. Okay, so it has 9 isomers. We commonly call it BHC, we call it 666, hexachlorocyclohexane, so many HCB, so many different names are famous for it. Now, we find statement B to be part of our answer, then that it is a true statement. Coming next, T is a heterocyclic compound. T is this last one that we formed. Where is T? Yes, T has a heterocyclic nature. So that statement is also true. It is a heterocyclic compound. So till here we have got ABC. Moving to D. R, on acid catalyzed intramolecular cyclization. First, let us check R. Where is R? Where is R? Okay, here is R. And for R, what they say? acid catalyzed intramolecular cyclization, what will be formed? Let me tell you first that this will be formed by intramolecular cyclization. Okay, followed by treatment with zinc amalgam and HCl, that is a Clemmensen reduction, right? Zinc amalgam concentrated HCl. If we'll do the reduction, then I will get reduction of carbonyls to alkane. Whereas the option says gives 9,10 dihydroxy anthracene. Let me tell you what is 9,10 dihydroxy anthracene. 9,10 dihydroxy anthracene is something like this, right? Which is not at all formed. It is not forming alcohol. It will form alkane. So D statement we did not find any correct. So let us conclude. Answer for question number 8 is A, B and C. Okay. Now we are moving to the numerical value questions.
So this is a question from gaseous state. Two cylinders, both fitted with frictionless piston, are filled with mixture of helium and argon gases. In the first cylinder, the mass of helium and argon are m1 and m2 respectively. In the second cylinder, the mass of helium and argon are m2 and m1 respectively. So masses of the gas is interchanged. The molar mass of argon is 10 times the molar mass of helium. The external pressure applied by the piston on the first cylinder needs to be 5 times that of the second cylinder so that the volume of gaseous mixtures in both the cylinders are equal at the same temperature. Assuming helium and argon behaves like ideal gases, the value of m1 upon m2. So if we try to draw a diagram to understand this problem, so there are two cylinders and the pressure applied on the first cylinder is P1 and it contains helium gas. The mass of helium gas here is M1 and the mass of argon gas is M2. M1 and M2 is the mass of helium and argon gas respectively. In the second cylinder, the pressure is P2 and the mass of helium and argon gas is exchanged here. The mass of helium gas is M2 and the mass of argon gas is M1. And it is mentioned that the volume of this container and this container is same, the temperature of this container and this container is same, but the pressure they have mentioned that the external pressure applied by the piston on the first cylinder needs to be 5 times. Obviously the pressure applied by on the piston is balanced by the gas, so P1 is equal to the pressure of this gas mixture, and they are saying that P1 is 5 times of P2, means the pressure in this gaseous mixture and this gaseous mixture is different, and the pressure of the first gaseous mixture is 5 times greater than the pressure of the second gaseous mixture. So from here if I try to write that PV is equal to nRT, so because volume and temperature is constant, we can write that pressure is directly proportional to number of moles. So P1 is equal to or directly proportional to pressure. P1 is directly proportional to the number of moles in the gaseous mixture, that is equal to the molar mass of helium gas, molar mass of helium gas. So this is m1 divided by molar mass of helium gas is 4, and the number of moles of argon gas is equal to m2 divided by molar mass of argon gas is 10 times more than that of helium, that is 40. So this is one equation. The other equation, from this cylinder we can write that pressure P2 is directly proportional to the mass of helium gas is m2 now, and the molar mass will be 4, and the mass of argon gas is m1 now, and m1 divided by molar mass, which is equal to 40. So if I try to write here what is the value of P1 upon P2, P1 upon P2 already it is given, that is equal to 5. So 5 is equal to M1 divided by 4 plus M2 divided by 40 upon M2 divided by 4 plus M1 divided by 40. If you multiply the numerator and denominator by 40, we can write that 5 is equal to 10 times of M1 plus M2 divided by 10 times of M2 plus M1. If we cross multiply, we can write that 50 times of M2 plus 5 times of M1 is equal to 10 times of M1 plus M2. And taking M2 on left hand side, I can write 49 times of M2 is equal to 5 times of M1. And they are asking the value of M1 by M2, which is equal to 49 by 5. If we multiply the numerator and denominator by 2, numerator becomes 98 and denominator becomes 10. So this value is equal to 9.8. So I think this is a simple question based on gaseous state. PV is equal to nRT. Let us move to the next problem. So our next problem is regarding coordination compound. A total number of all possible isomers for the square planar complex with the formula. So formula is given here, and this is a ambidentate ligand, and this is also a ambidentate ligand, and this is a bidentate ligand whose structure is given. The donor atoms here are different. One is nitrogen and the other is oxygen. So if I try to draw the structure, square planar structure, so I can say that the bidentate ligand is always present at cis position. Since the donor atoms are different, I can write A and B. And here there are many possibilities of linkage isomerism because these two are ambidentate ligands. So we first try to write about this structure. If I try to draw here, this is the bidentate ligand, and these are two monodentate ligands, right? So since the ligands are different, the donor atoms in these particular two cases are nitrogen only, but since the ligands are different, I can write that this is C ligand and this will be D ligand, and they are monodentate ligands. So this is the square planar geometry of this complex. So how many these complexes we can draw if we try to write that linkage isomers possible for this complex? One is this complex itself, that is MnCs NO2 GLY. Now the other is I can make the linkage isomer of NCX. Here the donor atom is nitrogen. If I reverse it, the donor atom will be sulfur. So I can write that this is KMSCN NO2 GLY. This is another linkage isomer to the first one. Now there is another possibility. I will keep this as same. So MnCs, the first ligand which is ambidentate ligand, but I am keeping it same, but I am changing the position here, changing the donor atom as oxygen. So this is another possibility. This is a bidentate ligand, keeping it at the cis position, right? This one. Now another possibility is there that both of these, if I reverse, right? So I can write that this is M, this will be SCN, then this will become ONO GLY. So there are 4 linkage isomers to this compound, and now we are discussing about the geometrical isomerism in each, because if you see all these 4 structures, if I try to show you here, they are square planar, right? So in this square planar geometry, you can see that this yellow color ball, right, this one is acting like a central atom, and this is the bidentate ligand, and this is the CH2 group where 2 hydrogen atoms are there. So in this, if I try to cut a plane, right, I am cutting this whole molecule by a plane parallel to the molecule, there is a plane of symmetry. So obviously there is no optical isomerism in a square planar complex. In this particular square planar complex, there is no optical isomerism. And if I am talking about geometrical isomerism, since the bidentate ligands are same, right, these ligands are same, but the position of these ligands can be changed. So if we try to write the geometrical isomer, in the first case there is 2 geometrical isomers for this complex. In this case also the bidentate ligand will remain same, but we can change the position of monodentate ligand. So here also 2 geometrical isomers will be there. In this case also there are 2 geometrical isomers, and similarly in this also there are 2 geometrical isomers. So if we are discussing, the total number of isomers for this complex is going to be 8. There is no optical isomerism. So there is linkage isomerism. Based on that, we can form 4 complexes, and all these complexes have 2 geometrical isomers. So total of 8 isomers are possible for this complex.
So the next question, the sum of total number of carbonyl groups present in the major product X and Y in the following reaction is. Now the carbonyl, lot of people are confused that should we take carbonyl only to be aldehyde and ketone, but NCERT has clearly mentioned that a carbonyl group is a C double bond O group. When is connected to H, then aldehyde. When is connected to some alkyl, it is ketone. When it is connected to OH, it is carboxylic acid, but they have mentioned it is carbonyl. When it is connected to chlorine, it is acid chloride, and all those acid derivatives were included in this definition in the opening comment or in the opening para of this aldehyde, ketone and carboxylic acid chapter. Okay, so we have to take as per NCERT that the total number of carbonyl will be all aldehyde, ketone, acid and derivatives. So now let us identify what are X and Y. The sum of total number of carbonyls to be taken in X and Y. First reaction. If we see this first reaction, see this is ketone, this is acid. For this acid, alpha, and then this is beta keto acid positioning. And for this one also, it is alpha and beta keto acid position. So if we heat this compound, that is CH3C COOH H C double bond O CH3CH COOH. If you heat it, then these beta keto acid heating will result in loss of 2 molecules of CO2. They will be released as gas. And what we are left with, let us check 1, 2, 3, 4, 5. So 1, 2, 3 will have carbonyl, 4 and 5. This is our structure for X. How many carbonyl groups are there in this X? 1. Let's go to second question, second reaction, which gives us a cyclopentanone 1, 2 dicarboxylic acid. Now see, this is not a beta keto acid positioning, right? For this acid, this is alpha, this is beta, now this is gamma. So there is no beta keto acid heating thing is applicable here. Now what is this relative positioning? See 1, 2, 3 and this is fourth, right? 1, 2, 3, 4, 1, 2, 3, 4, succinic acid type. And this is given on wedge. So hydrogens are on dash. This is on wedge. Somewhere here hydrogens are on dash, right? So they are on the same side. If it is heated, water molecule will be lost and the product will be an anhydride. Let us draw CO, C double bond O. This type of anhydride is formed. Now in this anhydride, how many carbonyls you will take? 1 and 2. Okay, so in X we have got 1 carbonyl. This is our Y. In Y we got 1, 2 and this original one, total of 3 carbonyls. We had to answer as the sum of these two. So answer we'll put is 3 plus 1, 4. Is that clear? The answer we have to mark is 4. Moving to question number 12. What is question number 12? Treatment of 1,3 butadiene. 1,3 butadiene matlab CH triple bond C triple bond CH with NNH2. In bracket it is given, we are allowed to use 2 equivalents. So C triple bond C triple bond C, Na, acid base reaction will take place, right? This is what we'll obtain on reaction of terminal alkynes with NNH2. Now this is treated with excess of what? Trans CH3 C double bond C trans. So I have to write like this, CH2BrH. What reaction do we expect? SN2. What type? Like this C minus will attack here and bromine is gone. Similar reaction from the other end on the next molecule, right? Because again they are mentioning excess of this compound is taken. Take gives X as the major product. So let us draw the possible structure of X. This is our trans to butene CH2. Now it is connected to 1,3-butadiene. Correct? This. So this is our structure of X. Now with reference to this X, what is the question? The maximum number of carbon atoms, not in general atom, carbon atoms that are collinear, that is they are falling on one straight line in X is. So let me show you, this is the structure. I hope you can see the structure. This here is diene portion, triple bond, right? Is it visible? Then it is bonded to, see this portion, I haven't put the hydrogen here, but I guess you can see how this trans structure is. Right here, carbon, this is the double bond, right? And then this formed with this. So check, so many atoms of carbon are there. Yes, about a single bond you can also have conformations, but in a straight line at any point of time, how many carbons could be in a straight line? Let us see. Let me help. 1, 2, 3, 4, 5 and 6. So whether the rotation are there or not, even if I leave it, see, anytime it is this 6, right? Now let me add a further information that these 6 only carbons being asked will continue to be our answer. Okay, if they would have asked in a single plane or anything, definitely there could have been many more, but on a straight line, 1, 2, 3, 4, 5 and 6. So answer for this question is 6. Question number 12, answer is 6. Now we are moving to section 4, which is of list 1 and list.
So this question is a mixture of 2-3 topics. Like I can see that surface chemistry is there because they are discussing about physisorption. Then diamond converted into graphite you can take in thermodynamics, and then denaturation of protein we do a practical in surface chemistry to make a colloidal solution of albumin, egg albumin. So that is a protein where we discuss about denaturation of protein. And the last option is isomerization. I think propene is converted into cyclopropane, and in all these questions they are asking about the sign of delta H and delta S for the process. So let us start with the first process P, where we are talking about physis option. Either I'm talking about physis option or chemis option. Adsorption is endothermic process. So physis option, when we are discussing about the gas particles are going to attach with van der Waals forces on the surface of a solid. So there is weak van der Waals force of attraction, there is a bond formation. Whenever bond is going to form, energy is going to release, so delta H is going to be negative here, energy is released here, so delta H will be negative. So it's an exothermic process. When the molecules are free, they can move, but when they are going to attach with the solid surface, they are bounded, they cannot move easily, right? So the entropy of the system is going to decrease, so delta S will be negative. Delta H is negative and delta S is negative, both are negative. So if we try to match here P option, delta H negative and delta S negative, that is matching with the two option, right? So we can say that P should be matched with 2. P should be matched with 2. Now moving to the Q option, conversion of diamond to graphite. I can prove this process will be exothermic process that can be proved with the help of thermochemistry also. Diamond to graphite conversion. So we can write that delta H of this reaction is equal to delta H naught or delta H combustion of reactant, which is diamond, minus delta H combustion of graphite. And heat of combustion, we know that the chemical species which is thermodynamically less stable has more magnitude of heat of combustion. So here if I am trying to write some value, suppose if I am saying that this is minus A, where the magnitude of A should be greater than the magnitude of B. This is the heat of combustion of graphite. Graphite is thermodynamically stable, so its heat of combustion, the amount of heat energy liberated during combustion of graphite will be less. Here A is greater than B. So if we try to simplify that, this value is equal to B minus A, and A is greater than B in magnitude, so this is going to be negative. So we know that conversion of graphite to diamond is endothermic process, so the reverse will be an exothermic process. So delta H for this is going to be negative. And diamond, we know that diamond has three-dimensional network solid where each carbon attached atom is attached with 4 carbon atom, while in case of graphite there is HCP structure of graphite, the sheet-like structure, but between the two sheets there is van der Waals force of attraction, right? So if we discuss about the entropy, we can write that the entropy of graphite is greater than the entropy of diamond. So if diamond is converted into graphite, the entropy change for this process is going to be positive. So entropy change is positive and enthalpy change is negative. If we are looking for this, delta S is positive and delta H is negative, we are getting this fifth option. So we can say that Q should be matched with 5. Q should be matched with 5. So 2 should be matched, P should be matched with 2. So this option, and then Q should be matched with 5. So C option as well as D option, till here we are not able to get the answer, right? So let us discuss the two other parts. Till now C and D, any option can come. So let us discuss the other two options. So our option, we are discussing about denaturation of protein, and in lab we are trying to make lyophilic colloidal solution, lyophilic colloidal solution. And one of the example was egg albumin. So the white part of the egg, when we break the egg, the white part is a protein which is known as egg albumin. And we know that if we try to make a colloidal solution of egg albumin at room temperature, we take distilled water and we mix egg albumin into it at room temperature, and mixing will make the colloidal solution. We should not heat it, because on heating there is denaturation of protein which is going to take place. So we know that if I try to predict logically about this process, what is entropy change, we know that entropy change is, if I am writing a small change in entropy, ds is dq reversible upon T. So for denaturation of protein, we are going to heat it. So dq will be positive, temperature in Kelvin will be positive. So from here we'll say that the entropy change will be positive. So delta S is going to be positive, since we are giving heat to the system. Delta H is also going to be positive. So if we try to see, already we have decided that C and D option can come, but looking at this, again we are not going to reach with the answer, because in C and D both R is matching with 1, which is seems to be correct. So this is a very good question. You should have thorough knowledge about all the topics given here, and till end you cannot able to decide the answer, right? So moving to the S option, where we are discussing propene is converted into cyclopropene. So this is isomerization of propene. So propene is converted into cyclopropane, and in this we have to discuss that what is the enthalpy change and what is the entropy change. So I have a structure of propene where there is a carbon, this carbon is sp3 hybridized, and through single bond I can rotate this molecule, right? So in this molecule the conformations are more, or the degree of freedom is more, right? So this molecule is relatively stable with respect to cyclopropane, because in case of cyclopropane, if we convert into a cyclopropane, this angle is 60 degree, which is making a triangle over here because of 60 degree, and these all carbon atoms are sp3 hybridized. So their angle should be 109 degree 28 minutes, but in place of that the angles are 60 degrees. So because of that there is angle strain, there is torsional strain. So overall this molecule is very strained molecule, means this is having high energy. In terms of thermodynamics of a molecule is unstable having high energy, it means that when this stable propene molecule is converted into this unstable molecule, this molecule has more energy, means the energy is absorbed. So conversion of propene to cyclopropane is an endothermic process. From here logically we can say that delta H for this process will be positive. Coming to the entropy change, entropy means degree of freedom. So here when we are talking about this propene molecule, these propene molecule, this carbon atom can rotate more freely, right? So the freedom on this molecule will be more. As soon it is converted into a cyclopropane molecule, these bonds are locked now, they cannot rotate, so the freedom of this molecule is less, right? So because of that, because of this cyclomerization, the entropy is going to decrease. So we can say that the entropy change for this process will be negative. So looking that option, we can say that C should be the answer for this, because here S option is matched with 4. The enthalpy change is positive, but the entropy change is negative. So we can say that this question may be one question which is given to decide the rankers, right? All the 4 options are very good options. Without solving all the 4, without knowing all the 4, you are not able to reach the answer. So let us move to the next question, question number 14. Question number 14 is from chemical bonding, right? So they are talking about many compounds, and list 1 and list 2 is given, and we have to find out how many of them has the given geometry like seesaw, T-shaped, trigonal planar and square planar. So let us discuss one by one. So moving to the first molecule, SOCl2. This molecule, the central atom is sulfur. So if I try to find out the number of hybrid orbitals in this molecule, valence electrons on sulfur is equal to 6, number of monovalent atoms is equal to 2 divided by 2. So from there we are getting that this number of hybrid orbitals will be 4. This molecule, the sulfur atom, should be sp3 hybridized. Now if we try to draw the structure of SOCl2, sulfur has 6 valence electrons. So if we try to draw the structure of this sp3 hybridized, this is sulfur double bond oxygen. There are 2 chlorine atoms over here, and there is a lone pair on sulfur atom. So if we look up to the structure, this is a trigonal pyramidal structure. Trigonal pyramidal. SOCl2 has trigonal pyramidal structure, and there is no trigonal pyramidal over here. This is trigonal planar, not pyramidal, and this is a square pyramidal. Okay, so moving to the second option, XeOF4. Again, if we try to find out the number of hybrid orbitals on the central atom, which is xenon, so 8 electrons are there in valence shell of xenon, and there are 4 monovalent atoms divided by 2. So the number of hybrid orbitals is equal to 6. Hybridization will be sp3d2. And in this, if we try to find out the number of bond pairs, means surrounding atoms are 5, and there will be 1 lone pair on this. So it is a square bipyramidal geometry, and all positions are equivalent. So if I am putting here lone pair, opposite to lone pair, it will be better to put the pi bond because it need more space. So they are opposite to each other, and now the 4 fluorine atoms are there in a square plane. So this is the structure, and if we try to draw, it will be square pyramidal, right? So this is a square pyramidal geometry. Okay, so moving to the third compound. The third compound is ClF3. In case of ClF3, the central atom is chlorine. If we try to find out number of hybrid orbitals, 7 plus 3 divided by 2, that is 5. So the hybridization will be sp3d. The surrounding atoms, means the bond pair is equal to 3 and the lone pair is equal to 2, and whenever we have to place the lone pair in trigonal bipyramidal geometry, first we place them on the equatorial position. So from here we are getting that it has T shape. So ClF3 molecule has T shape. Moving to the other molecule is XeF5, fourth molecule. Here we are writing, sorry, ClF5. So in case of ClF5, the central atom is chlorine. The number of hybrid orbitals is equal to 7 plus 5 divided by 2. So that is equal to 6. Bond pairs means surrounding atom is equal to 5 and the lone pair will be 1. So from there we can say that lone pair and is 1. So same type of a structure we can see that it has a square pyramidal structure. So this has a square pyramidal structure. Till 4 we have discussed. For the remaining molecules, let us move to the next page. So here XeF5 plus is there. Central atom is xenon. If we try to write number of hybrid orbitals, 8 electrons are there in the valence shell. There are 5 surrounding atom, but it has lost 1 electron divided by 2. So this is 12 divided by 2. So hybridization will be sp3d. Again, bond pairs are 5 in number and lone pair will be 1. So from here we can say that the molecule will be square pyramidal. So this is also a square pyramidal. So the first molecule was trigonal pyramidal. Then the second molecule we have find out this molecule. Let us go to the last page and find out what was the molecule. Second molecule XeOF4. It has a geometry of a square pyramidal. So square pyramidal, then the third one is T-shaped. So let us write on the next page. So this was a square pyramidal, then this was T-shaped, then this molecule is again a square pyramidal, and we have discussed this is also a square pyramidal. Now moving to the next one, the sixth example is SO3 2 minus. We can draw the structure, or we can calculate the number of hybrid orbitals. Central atom is sulfur, valence electron is 6. It has taken 2 electrons, divided by 2. So this is going to be 4. Hybridization is sp3. If we try to draw the structure of this, sulfur has 6 electrons. So there is 2 oxygen atom with single bond, they have negative charge, and 1 oxygen with double bond. So this is the structure. Again, this structure is trigonal pyramidal structure. So this again has trigonal pyramidal structure. Then the seventh example is XeF3 plus. So number of hybrid orbitals is equal to 8 plus 3 minus 1 divided by 2, which is equal to 5. So hybridization will be sp3d. The surrounding atoms or bond pairs is equal to 3. So the lone pair is equal to 2. And if we try to put the lone pair on the central atom, we put in equatorial position. So again, this molecule should have T shape, right? So this molecule should have, or ion should have, T shape. And the last molecule is SF4. So in case of SF4, number of hybrid orbital is equal to 6 plus 4 divided by 2, which is equal to 5. And bond pairs will be 4, and there is one lone pair. Here one lone pair is there, right? So from there, if we try to simplify it, we can draw sulfur atom. Lone pair should be present on equatorial position. So this will be the lone pair. And fluorine atoms, 2 at equatorial and 2 at axial position. So from there we can say that this molecule has seesaw structure. So now let us try to find out the matching seesaw molecule. We have find out 1, so P should be matched with 1. Then T-shaped molecules we have find out 2. T-shaped molecules should be 2. Then trigonal planar, if we see there is no trigonal planar molecules, so there is 0 molecules having trigonal planar geometry. Square pyramidal we have calculated, and for a square pyramidal, this molecule is a square pyramidal, then this one is a square pyramidal, and then this molecule is a square pyramidal. So there are 3 molecules having a square pyramidal geometry. I think options are missing here, right? So from this you can find out what is the proper answer for this question. And if you go through the paper, you will find out that first option is given, in which A option, P is matched with 1, then Q is matched with 2, then R is matched with 5, and S is matched with 3. And it is matching, right? So answer for this will be A option. A should be the answer for this.
Mhm. So this is the list 1 and list 2 match question. The list 2 contains products obtained from the reaction of compounds in list 1. List 1 compound is to be treated with ozone, followed by cyclization via more stable enolate, matlab more substituted enolate in the presence of aqueous NaOH. Match each entry in list 1 with appropriate entry in list 2 and choose the correct option. So we have to have 2 reagent sequencing. Let us take one by one. So it is starting with P, Q, R, S, and other side we have 1, 2, 3, 4, 5. Okay, so let's move the structure P first. Now the P is given to be a fused structure like this with 2 CH3 placed here. As I have already read in the question, you have to take ozone followed by zinc and water. Okay, so what will ozone do? Ozone will break this bond. If there would have been aldehyde, then zinc is there or not would have played a role, but not here. So I would like to number this whole thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So when this structure will open, excuse me for the incorrect representation, but to continue with more accuracy, I will prefer this type of representation, right? As it will not let me do any more if and but errors. Like, let me repeat the position: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? This is after ozone-lysis. Now we have to take it with NaOH heat, right? They have said in the question, followed by cyclization in the presence of aqueous NaOH, we have to use the more stable enolate. Okay, even heat is not given. Okay, fine. So we won't be dehydrating, just adding. Now, overall, it is a symmetrical structure. Each carbonyl has one substituted and one non-substituted site. More stable enolate, so substituted one will be the more stable. I will attack, say, from this position to here. So 1, 2, 3, 4, 5, and the rest is a 6-member. Oh no, 6 Q 7. See, 1, 2, 3, 4, 5, 6, and 7. So other side I will have a 7-member ring, and other side a 5-member ring. And the junction point is 1 and 5. So this is going to be 1 and 5. Fifth one will have this CH3, right? One will have the OH, as it is an aldol condensation they are considering, right? Now fifth is bonding. Sixth will have a double bond O. 6, 7, 8, 9, 10th. 10th is having one methyl. Let us complete numbering here also. 1, 2, 3, 4, and this is 5. So looking at this structure, 7-member ring is having carbonyl and methyl. No substitution in 5-member ring. Let us go back and check which structure is suiting this. See, 7-member ring, methyl carbonyl, no substitution in 5-member ring. So what we are matching or what we are getting here is structure which is placed at number 2. So we'll match P with 2. Proceeding to the next subpart, compound 2. Compound 2 is a 7-member substituted cyclohexane. Now it is fused with 5-member ring like this. Proceeding to same process, ozone, zinc, water will break. Overall, it is like 7, 8, 9, 10. So carbon count will remain same, right? And here also we have 2 methyl as above, but the relative positions will change. So let us do the numbering again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so if I break this, I'll get 1 and 5 as carbonyl, making it same as above, right? 1, 2, 3, 4, 5. This is 5. This is having carbonyl. Okay. 4 is having methyl. So let me put methyl. Okay, 5, 6, 7, 8, 9, 10. 10 is again having methyl. Now again we have to go for aldol with NaOH aqueous as mentioned. 10 is having two neighboring alpha H, either 6 or 4. And same applies to carbonyl 1, either 10 or 2. Any one we can use. But here we definitely have to be very careful with what site or where I should attack so as to have a stable 6-membered structure, right? We should have a stable 6-membered structure. So if I attack from this 10 to 5, check what is the count of the ring. 1, 2, 3, 4, 5, 6. That is quite perfect. The other side ring will be 1, 2, 3, 4, 5, 6. So we are getting two fused rings which are both 6-membered rings. So that is a good structure, stable enolate using. So perfect for our answer CH3 OH CH3 carbonyl. How I drew it directly? Using the number. 10th one I was attacking on 5. So I directly will put 10 and 5. Rest I'll start 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And we had 10 पे CH3 and 4th पे CH3. Yes, we got 5 and 10 given. Go back to the list. See, 2 6-member. One ring has nothing. Bridgehead has CH3OH and carbonyl and CH3 are up front. So this seems to be structure number 1. So Q will be matched to structure number 1. Repeat the process for R. In case of R, we have quite similar to this Q, but slight position change. Like what is the position change? They have this 5 and 7 ring, but the methyl is now here only. Both methyls are in 7-member ring. Repeat the process. Ozone, zinc and water. Break 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let us repeat. Okay, so 1 and 5 will have the bonds 1, 2, 3, 4, this being 5. 6 and 10 should have methyl. So here there will be methyl. 6th will be methyl. 7, 8, 9 and 10. Again, the ring closure, if we say, should be of a stable enolate and carbonyl, forming a stable structure. So it appears that again I will have two 6-member ring, okay, but the junctions which I should have this time are slightly different. In this, one ring had nothing, whereas in this, one has carbonyl, other has methyl. Okay, and that too on opposite side. So one has carbonyl, other has methyl. I hope you can see the structure. It is hiding behind me, I guess. So let me move a little. What can you see it now? Right? CH3, OH and CH3. So it appears that the structure number 5 is this. So we have got P to 2, Q will match to R, sorry 1, R will match to 5. Now moving to the last thing, that was S. S is 2 6-member. So this is a little modification from your P option like this. Same thing, ozone, zinc, water, but the positions are the only concerns, right? Oxygen, oxygen, 2 CH3s, same way, NaOH aqueous, right? It will have 7 and 5-member ring fusion because it is a copy of P. But the positions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let us repeat 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, and the ring is closing between say 10 and 6, or you can say 2 and 6. Okay, either side we can say. So if I say 2, okay, if I'm using 2 and attacking on 6, okay, so 3, 4, 5, 6. Seventh is having a methyl. 8, 9, 10, and this is first. Okay, so first will have a carbonyl and 10th will have that extra methyl, right? So 7-member ring will have carbonyl and methyl. Let us check once again what I have drawn. 1, 2, 3, 4, 5, 6. Using stable enolate, I have to go for 10 to 6. So, sir, I should remove this one, right? Let us I hope all of you have got, because table enolate 10th should attack on 6. If 10th attack on 6, again 5-member ring. Let me draw that 5-member ring. Here is 10th, 9th, 8th, 7th. 7th is having methyl. 6th will have OH. Rest is a 7-member ring. Let me draw 7-member ring. Right? 6th ka neighbor is 5, 4, right? 3, 2, and here is 1. So now my 5-member ring will have the methyl and 7-member ring will have a carbonyl. Let us check which is this structure. 7-member ring carbonyl, 5-member ring methyl, and bridgeheads as follows. So this seemed to be structure number 3. So final match P2Q1. P2. Okay, so these two options gone. Q1, it seems to be this is a chance. Let's see others. R5, S3, recheck. R5, S3. Okay, so the correct answer for this question should be C option. Okay, so this is C option. Let us move to the next question. Match the major products obtained in reaction given in list 1 with the corresponding structures in list 2 and choose the correct option. Now first you should know this is not a Beckmann rearrangement. Yes, there are lot of oximes, oxime, everywhere it is an oxime. But the oximes involved are not reacted with acidic medium. Beckmann takes place in acidic medium, whereas here the reactions are given with basic medium. Okay. Now, as far as the basic medium is concerned, the entire question detail you will find the full detail from IL Finar volume 2. That entire question is from this, where the topic determination of configuration of aldoximes, and in continuity for 2-3 pages you will find ketoximes also. Directly evident. See, Na2CO3, NaOH. Where is NaOH? Here NaOH. Okay. Now let me explain how the question is carried out, what they have done. First, see what is happening in option number P. Let me do P. In case P, you see the suitability of the position is very much for SNAR. Okay, NO2 ko para bromine is given. Now here, this OH, it is an aldoxime, other side is H. Now, the reagent given is aqueous NaOH. NaOH being base will take acidic H from here. So OH minus will take acidic H. O minus is formed. O minus will do SNAR and we'll have this substitution. Very good. We'll do this substitution and see what we'll have. We'll have NO2 here we'll have oxygen, double bond N, which is bonded here, and H, right? But the conditions are basic, and this H plus is still suitably placed NT position, that if it is taken as an acid, you will have this type of bond fission. This type of bond fission, so NO2, this H is gone, so this is becoming C triple bond N. This bond is being broken, so I'll say O minus. But as the conditions are aqueous, I'll write OH. Okay, so 1, 2, 3, 4. Relative positioning, not the IUPAC positioning I'm marking. NO2 ka third position I need CN, and fourth position I want OH. It seems structure 1. Okay, so what we are getting is structure number 1. Now, when the similar thing, I want to go for R. Okay, I'll come to Q later, moving to this R option. Similar in the sense, see the structure difference between P and R is the CH3. Okay, it is a ketoxene. It is a ketoxene. This type of thing will happen here also, CH3. Okay, suitably placed bromine. I will have the relative SNAR that will be done. Correct? And yes, condition is of OH minus, but this is no more acidic. In case of aldoxenes, we had this H suitably oppositely site placed, which was acidic, and we could remove it and form cyanides. Now, this cannot attack this CH3. It is not to be removed like this. So, no further reaction, and you have to end with this cyclic structure. As a result, I want R to be matched with, see this fourth. Okay, so this was structure number 4. I hope you have got the difference. In case of aldoxenes, that H is capable of removing, so we are doing. In case of ketoxene, the alkyl group cannot be removed by base, and therefore it continued to be placed so, and the cyclic product is taken as a answer. Now let us see the other two options in which they are using acetic anhydride. Here they have already attached, but acetic anhydride is to be reacted followed by Na2CO3. Let us do that. Okay, so let us have a fresh page to write those reactions. So now option or list 1, second compound Q. First, let me copy the structure. Bromine, C, double bond N and OH. Nitro is placed as such. Okay, first I will do acetylation because the reagent given is CH3 COO whole twice oxygen. It is an anhydride, so H plus will go and I will have acetylation. Okay, very well. Let me write what will I get by that acetylation. C double bond N O C O CH3, and this side is again H. Okay, this side is again H, and NO2 of course continued. And conditions are of Na2CO3 aqueous. We have to take aqueous as nothing is mentioned. Now again I will have this H to be abstracted, but there is no cycle. When it was attached to cycle, SNAR was there, then I would have done a change here. No effect on this bromine. This coming acetate being a good living group left. So I will have NO2 bromine here itself and C triple bond N, cyano and bromine. When you will check, I think this is structure number 2. This will be structure number 2. Now see, this was aldoxime, here was H. So we took H is removed and the good living group left. If the same thing is asked on ketoxime, bromine C double bond N OH. Oh, let me see, they have already given the acetylation prior done. So I don't have to do the acetylation. Let me see what is their structure given. They have given OCOCH3 and then aqueous Na2CO3. Aqueous Na2CO3. But the thing is, if I will remove this, I don't have a suitable leaving group which can leave concertedly or simultaneously. That is not possible this time. And if I cannot have this, what will I do? I will have simple hydrolysis of this ester type linkage, and as a result, NO2 bromine CH3 NOH. And the position, see, if this bond would have been broken, it is a chance that I could have either side, cis and trans. But the option is clear that this bond is broken, not this. So there is no change in this bond. It remained as it was given in the original compound. Now let me check this structure is number 5. So Q we matched with 2, S we matched with 5. Q we matched with 2, S we matched with 5. Right? Let us check options. Q with 2, S with 4. No. Q with 2 and S with 5. So it seems a possible answer for this question could have been B. Let us check the other options. P we matched with structure 1. Yes, it matched. Q with 2. R we matched with structure 4. Yes, it matched. And S we matched with structure number 5. It matched. Definitely then answer for this question number 16 has to be B option. Okay, and I think that brings us to the closure of paper 1 of JEE Advanced 2026. It had 16 questions with different possible patterns. Like first 4 were single correct, then there were multi-correct 4, then there were decimal, or I should say numerical types till second place decimal. We had 4 questions, and lastly the 4 list match. Total marks were, I guess, 60, right? 60 was the total because the entire paper PCM was 180. The quality of paper is definitely quite good. Moderate to tough, we should range this particular paper. There were few simple questions, but otherwise it definitely demands proper time and concentration to get good marks in this particular type of paper. As far as question 16 is concerned, it is slightly here and there, not exactly from NCERT, but if you exclude 16th, rest 15th are directly from NCERT, right? In case of 16, I would still not say that it is an objectionable question. Why? Because I guess if you know the SNAR reaction, an aromatic substitution, then this option you match. Just match that R option, and only one out of A, B, C, D has R matched to R, to fourth structure. Okay, so you have SNAR in your syllabus. It is a question that checks your aptitude, that under pressure condition you are there to manage the best outcome, or you get confused, nervous, invest lot of time and leads nowhere. So overall, it is a wonderful paper. Wish you all the best for the results and the final keys. See you again in the next paper discussion. Thank you everyone. Bye-bye.